Okay, good morning, good afternoon, wherever you are, depending on when you're watching this. Today we're going to be talking about two-dimensional figures. Once again, a lot of vocabulary, and then a couple things that you may or may not have heard of before, okay? First things first, a polygon. Polygons are a closed figure, so right, it has no openings. For example, this has an opening in it, right here, right? This has an opening in it, right? So it has to be closed. Each side connects exactly to two other sides, right? So if you look at this side right here, right? This side is touching two other sides, right? This one right here, right? It's touching, see, 1, 2, 3 other sides, right? You could even say 4. So it can only touch two sides. And the entire figure is closed. See how it's not closed here? See how it's not closed here, right? And the other big one, I think it mentions it somewhere. Straight sides? Does it say that anywhere? No, it doesn't really say that. But it also has to be straight lines. So for example, this doesn't work. This doesn't work because they're not straight lines. Okay? I'll give you, the best way to do this is this. If I asked you to draw a shape, you'd probably draw a polygon. You would probably not draw one of these, right? So a polygon is just a normal figure. All right, the next one is called convex or concave. Now the way I like to think of it is like caving in. See how this is caving in right here? Right? That's concave. If I asked you to draw a shape, you would probably draw a convex shape. So most people would do convex. So let's look at something real quick here. All right, so there's another way to tell if something's concave. So if I was to draw something that I think might be concave, right, like this, and then draw something that is not concave, right, something like this. Now watch what happens. If I draw a line through a side, right, I'm going to do this in another color. See how it cuts through the shape? If it cuts through the shape when you draw a line on a side, then it's concave. If it does not cut through the shape, then it's convex. So this one cuts through the shape right here, and this one cuts through the shape right here. So that's why it's convex, or that's why the second one is convex and the first one is concave. So that's another way to identify when you have one or the other. All right, convex, concave, equilateral, all the sides are equal, right? That's this one here. Equal angular, all the angles are equal. And then regular means all the sides and all the angles are equal, all right? And then the last, so a lot of vocabulary, let's summarize it. Polygons, right? Closed, straight-sided figures, right? Convex, concave, right? That if sides cut through the shape, they're concave, right? Convex do not. Equilateral, all the sides are equal. Equal angular, all the angles are equal. And then you got regular shapes, right? We also need to look at these right here. I was able to snip these for you. So a three-sided polygon is called a triangle, you know that. A four-sided is not a square, it's called a quadrilateral. 5 penta, hexa, hepta, octa, nona, deca, hendeca I didn't even know, so dodeca I did. So anything past 12 on our homework tonight, you can just call an entagon, right? So if it's 50-sided, you could call it a 50-sided agon, okay? All right, first question here. Tell if each is a polygon, if it's convex or concave, regular or irregular, and then give it its name, all right? So first things first, is this a polygon? Yes, right? It's closed, right? No straight, all straight sides, so yes, it's a polygon. Right? Convex or concave, well, since it cuts through the shape, it's concave. Regular or irregular, all right? Oh, there should be some other equal, we need to add these. Equilateral, equal angular. Okay, equilateral, equal angular. Okay, you see these little tick marks, right? these little tick marks mean that all the sides are equal. Since all the sides are equal, it's equilateral. All right. Now look, these two, I'm going to do this in red. These two sides, these two angles are equal, and these two angles are equal, but not all five, right? So this is not equal angular, it's only equilateral, right? Is it regular or irregular, right? Well, it's irregular because it's not equal angular, right? And then give me its name. Well, it has 1, 2, 3, 4, 5, 6 sided, so it's a hexagon. So it's an equilateral hexagon. All right, next one. Is it a polygon? Yes, it's a polygon, right? Right, convex or concave? Definitely convex, right? Nothing crosses through the shape. All the sides don't cross through the shape. All the sides are equal, so it's equilateral. Notice all the angles are equal, so it's equiangular. Now, if it's equilateral and equiangular, that makes it regular. Now, you don't have to write these two. If you just write regular, I'll give it to you. That's the same thing as saying it's equilateral and equiangular. And then what kind of shape is it? Well, it has, let's see, 1, 2, 3, 4, 5, 6, 7, 8 sided, so it's an octagon. All right, pretty simple, right? Just a lot of vocabulary. All right. Next part here, we do have some formulas that you need to know, right? Perimeters and areas. I'm not going to go into too much detail here. You should probably pretty much know these by now. Be careful with the triangle. It's 1/2 base times height. One thing that's probably good to talk about on the triangle real quick is if this is the base, and I make this imaginary line up here that's parallel to the base, and I draw a triangle from here to here, and I make it, right? If I go over here and I draw a different triangle, I don't have blue, do I? All right, I'll have to do it in red. And I come over here and I make this triangle. What's interesting is that these two triangles have the same area. In fact, if I go over here and I draw another triangle, like this, all three of these triangles have the same area. The reason for that is this. This is the height, this is the height, this is the height. They all have the same height. They all have the same base, they all have the same height. No matter where I put it, no matter where I put it on this line, the areas are going to be equal, all right? So how do I measure the height? The height is measured from the top of the triangle straight down. So if I was to make this triangle here, right? Here's the base, the height is this distance right here. Not this. This is not the height, yeah? Not the height. This is the height right here, that distance. So it's kind of like, the way I like to think of it is if you were standing here, right, and you dropped a string, the string would go straight down here. That's the height, okay? All right, so first things first, find the area and the perimeter of each of these. All right, well, area of the rectangle is just going to be base times height, right? So it's going to be 3.2 times 2.1. I'm not going to spend time on the crunching of numbers here, so 3.2 times 2.1 is 6.72, right? 6.72. Since it's area, it's square units, so centimeters squared, okay? Perimeter. Well, perimeter is just going around the shape, right? So you could do 2 bases and 2 heights, or you could just add up all the sides. The way I like to typically do it is I'd like to do 2 times 3.2 plus 2.1, right? What am I doing? I'm just saying I have 2 of those and 2 of those, right? Or another way of saying that is I'm adding up this plus this, and then I know I have 2 of those, right? So I have 2 times 5.3. So what is that? 10.9? No, 10.6. 10.6 centimeters. All right. Excuse me. All right. Area of a circle is pi times radius squared. That's given up here. So pi, we're going to approximate as 3.14. Sometimes we're going to leave it as pi. We'll get into that later in the year. Radius is 3, so this is 3 times 3. So we get 3.14 times 3 times 3. And that is, you know what, let me do this slightly different. Let me do it this way. Call this pi, right? So this is 9 pi, right? The area is 9 pi. In higher level math, we like to leave that in pi units. If you want to approximate it, so you don't multiply by the pi unless they ask you to, right? If they say approximate pi, then you're going to use something for pi, right? So if I use 3.14 for pi, then this would be 28.26. But I'll tell you, in a geometry class, this is a better answer. You got to look at the question to make sure that you're answering it, right? If they say approximate pi, then use 3 point whatever they tell you to use. If they say exact measure, then use pi units, okay? So circumference is 2 pi r. So circumference is 2 pi times the radius is 3, right? So this is 6 pi. Or if you approximate it, 6 pi is about 18.84. All right. All right, I'm not going to do both of these. I'm just going to do the first letter C. First, let's find the area. Area is base times height divided by 2, or another way of saying that is 1/2 base times height, right? So 1/2. The base is here because the base and the height make a t. Do you see that t there, right? So this is 10.2 times the height is 8. So I get 0.5 times 10.2 times 8. 40.8. The area is 40.8, just base times height divided by 2. The perimeter, now be careful when you're doing the perimeter is the outside, right? So because, let me erase all this. This is the perimeter, right? From here to here to here, not this middle section, right? So all you have to do for perimeter is easy, just add up the sides. 9.5 plus 9.5 plus 10.2, right? What is that? 19 plus 10.2. So that's 29.2. And go back to the units real quick. For area, it would have been, back at the circle, for area, it would have been inches squared. For circumference, it would have been inches. For area on letter C, it would have been inches squared. And for perimeter, it would have just been inches. Okay? All right, next problem, example 2. All right, find the perimeter and the area of the following quadrilateral. Well, first things first, to find the area or the perimeter, this is looking like it's a square, right? But we have to figure out how long this is. And we have to figure out how long this is, and how long this is, and how long this is, right? Well, remember, we can find the distance. We can find the distance from A to B, right? The distance from A to B is what? The square root, remember distance formula, right? The square root of how far between the x's from -1 to 2 is 3 squared, plus from -1 to 2 is 3 squared, right? So we get the square root of 18, right? I'm going to leave it as root 18. And I can do that for each side, and I'll notice something. If I do the distance from A to D, so if I do AD now, I'll notice that I get the same numbers, right? From -1 to 2 is 3 squared, and from -1 to -4 is 3 squared, so I get the same thing. Oh, okay, this is easy. Each side is root 18, right? So I'm going to erase all this. So this is root 18. This is root 18. This is root 18. This is root 18, right? If you want to be technical, root 18 is actually 3 times 3 times 2, so it's actually 3 root 2. If you want to get better with your answers, why don't we do that? Why don't we call this 3 root 2, because that's going to help us long term, right? So these are 3 root 2. All right. And so how do I find the perimeter? All right, let's do the area first. The area is 3 root 2 times 3 root 2, which is going to be 9 times root 2 squared, right? Root 2 times root 2 is root 2 squared. And when you square square root, you just get 2. So you get 9 times 2, which is 18. Right? To find the perimeter, you're going to do 3 root 2 times 4, right? Because there's 4 sides like that, which is 12 root 2. Now you got to be careful on your homework tonight. Do they want you to write it as a radical, or do they want you to approximate it? Because if they want you to approximate it, 12 times 2 root is 16.97. So let's call that 16 or 19? Yeah, 16. So call that 17.0 if you rounded it to the nearest tenth. Okay. All right. Example 3. What you're going to do is you're going to graph these points. 1, 2 is here, right? That's 1, 2, 2, 2, 3, 4, 5, 2 is here. That's 5, 2. And 1, 5 is up here, right? 1, 5. All right, so we got this triangle. Find the area and the perimeter. Well, I guess I'm going to call these A, B, and C, right? Well, we need to figure out how long AB is. We need to figure out how long BC is, and we need to figure out how long AC is. Now, the only hard one is BC. The other two are easy. AB is from 1 to 5, right? From here, I'm going to do this in green. From here to here is, from 1 to 5 is 4, so this is 4. BC goes from, what does it go from? It goes from 2 to 5. Oh, this is 3. Oh, cool. This is a 3, 4, 5 triangle, right? So that's 5, right? Because these are a right angle, right, with each other. So it's a 3, 4, 5 triangle. All right, pretty easy. Area. Area is going to be base times height divided by 2, or 1/2 base times height. The base is 4. The height is this distance right here. So this is 3. I feel like I made it. Oh, you know what? I did make a mistake. Darn it. Ah, it's not 5. It would have been much nicer if this was 5. Let me see. Did I make a mistake? AB was... Oh, no, it is. No, I am right. Ah, dang it. All right, to find the area, right, it's base 4 times height 3 divided by 2, right, which is 6. So the area is 6. The perimeter is going to be 3 plus 4 plus the 5, right? So 7 plus 5 is 12. 12 units and 6 units squared. All right, next problem. A rectangle whose length and width, right? Here's the width and here's the length. A rectangle whose length is 1/2 the width. So the length is half the width. So instead of L, I'm going to put 1/2 W. And I know the area is 72. So I know that 1/2 W length times the width equals 72. It's just a baby algebra problem, right? I get 1/2 W squared equals 72. So I get W squared equals 144. So I get W equals 12. What's the question? Find the perimeter, right? Okay, so I now know that this is 12. I know this is 12. I know these are half of 12, so these are 6. So I get 24, 36. So the perimeter is 36. All I'm doing, guys, you can go back and watch this video again if you need to, but all I'm doing is doing substitution, right? All right, so I got a circle with an area of 144 pi, right? Well, I know that area equals pi times radius squared. So I know that 144 pi, that's the area, is equal to pi times whatever the radius is squared. Divide both sides by pi, that will knock off the pi's, right? And I'm left with 144 equals r squared, so r is 12. That's it. Oh, that's the radius. Now we need to find the circumference, right? The circumference is 2 pi r, so the circumference is 2 times pi times 12, so we get 24 pi. All right? Okay, you know, I went a little bit fast here, but you can definitely go back and just pause the video, rewind it, whatever you need to do. All right? You'll have an assignment on this, but good luck with this. If you need any help, just let me know, and I'll be more than happy to help you. All right, take care. Bye.